Today's topic is hurricanes. Actually, it's hurricanes and other storms that spin, except not tornadoes. So it's like big spinning storms. That's today's lecture. All right, well, let's take a look at what I'm starting out here. This is billion-dollar climate and weather disasters from 1980 to 2005. And I put this up there so we can see the black shows which states had the most billion-dollar weather and climate disasters, and the purple, or light purple, I don't know, whatever color that is, shows which state had the least number of those. And you'll notice the most billion-dollar disasters all seem to be here in basically the southeastern United States. Well, why is that? If we look here, the disaster type and the number of events, the majority of the billion-dollar weather disasters were tropical storms and hurricanes. Following that are non-tropical floods, which means floods not related to the storms, the hurricanes and tropical storms. So really, when we are looking at these hurricanes, it's important to remember these cause a lot of damage. These are really some of the worst events that we can have, and some of the really, really costly events. All right, so this is our hazard map, like what I usually start with. And this shows the number of hurricanes expected to occur during a 100-year period based on the historical data. So the light blue areas, there's 20 to 40 of these storms in 100 years. In the dark blue, it's 40 to 60 in 100 years. And in the red, it's going to be more than 60. So, like Florida, guess what? You're going to be getting a lot of hurricanes in the course of 100 years. All right, so a hurricane is a large tropical cyclone. Okay, tropical refers to where it forms. When we talk about the tropics, we're looking towards more equatorial areas. If you ever hear the term extratropical, that means outside of the tropics. That's where we're getting to the higher latitudes. We're not close to the equator anymore. So this is a tropical cyclone. Cyclone refers to a storm that has spin to it. So any kind of storm with spin to it could be described as cyclonic. All right, so this is a large tropical cyclone in North Atlantic or the East Pacific. They get these tropical cyclones in other parts of the world. They just don't call them hurricanes. They're called typhoon. It's a typhoon in the Western Pacific, or simply a cyclone in the Indian Ocean. So if you ever hear like Japan is being hit by a typhoon, well, hey, it's a hurricane. It's just called something different in that part of the world. The way they work, the way they behave is the same. In this lecture, oops, that was fun. All right, in this lecture, we're going to focus on hurricanes in the Atlantic Basin, and that's because, look, we're here in southeast Texas. That's the storms that are going to be affecting us. So I'm going to really focus on the hurricanes that occur here in the Atlantic Basin, but just realize you get these tropical cyclones in other parts of the world as well. And this is basically showing where they form and the typical paths that they will follow. All right, so how do they form? Well, when you have these storms like this, there's the reason they form is to transport heat from the tropics. I know I said this in the weather and climate lecture, where your frontal systems and your storms are all there because Earth is seeking equilibrium. Nature wants balance, as all things should be. But it basically, too much heat reaches the equators and not enough reaches the poles. And so Earth basically has these weather patterns to try to distribute that heat around the planet. Earth is seeking balance. So, equilibrium, whatever you want to call it. It's necessary. But anyway, what are the ingredients to the storm, though, to try to develop it to transport this heat from the tropics? Well, there's three basic ingredients. You need warm surface water. And that's why you'll see these form, you know, when the Gulf of Mexico gets really, really hot, these things really like to form because you need warm surface water. You need unstable air. When we're talking about atmospheric instability and unstable air, this is warm and humid air that wants to rise. And then you need weak upper level winds. And you're probably like, but hurricanes have strong winds. Well, we're talking about when you get into the upper levels of the troposphere, you don't need strong winds there because that will basically decapitate a hurricane, because a hurricane needs these warm air rising, and if you have strong winds, it disrupts that so you don't develop the storm. So weak upper level winds, unstable air, and warm water are the ingredients to make a hurricane. And that's basically what we're showing right here. This warm, moist air moves over the ocean, water vapor rises into the atmosphere. As the water vapor rises, it cools, condenses. Condensation releases heat in the atmosphere, makes the air lighter, so it rises even more. So we have quite a bit of this rising, unstable air that's creating the low pressure we need ultimately to make our hurricane. And this is why we can't have those strong upper level winds or it'll blow all of this apart. All right. So when our hurricanes start forming, it's not like, you know, 1 minute we have nothing and then the next minute we have a hurricane. It doesn't work that way. They actually go through stages of development. Now sometimes they can rapidly develop, but they do go through these distinctive stages. We begin with a tropical disturbance. And this is where we have an area of low pressure that starts pulling in a little cluster of thunderstorms, and we don't have very strong winds at this point in time. And so, for instance, there's our tropical disturbance. It's just sort of this cluster of thunderstorms hanging out there in the Atlantic. Well, if conditions are favorable, so I just want to let you know, just because there's a tropical disturbance doesn't mean it's going to become a hurricane. It needs favorable conditions like the warm water and the weak upper level winds and all that kind of stuff. But if the conditions are favorable, it could develop into a tropical depression. And in this case, we start getting stronger surface winds, and there'll be a distinctive low pressure center. And at this point, it gets assigned a number. So you might hear like, this is tropical disturbance or tropical depression 15 that we're monitoring. Well, that's where it gets that number from. And here we have Invest 93, and that's our tropical depression right there. If conditions are favorable, it'll continue to develop and we will end up getting a tropical storm. And this is where surface winds meet at a central core, and these surface winds then rise, right? It acts like a chimney, so these warm air is rising. That's why we have this low pressure in the center of this tropical storm. And remember, air always flows from high to low pressure. So basically, the storm is pulling in air, it's rising at that low pressure center, and so our winds are getting stronger, and we have to have minimum sustained winds of 39 miles an hour. Now that's the minimum winds. We can have gusts stronger than that. Sustained just means constant winds. At this point, it's assigned a name. And right here, this is Tropical Storm Faye back in 2008. And that's what it looked like. Now, if conditions are favorable, that tropical storm will continue to develop and become a hurricane. And when you have a hurricane, you get a well-defined eye. That's where that low pressure center is. And our minimum sustained winds are 74 miles an hour. Now, gusts are going to be stronger than that, and in fact, your sustained winds can be much stronger than that, depending just how well this hurricane ends up developing. All right, so this is Hurricane Mitch back in 1998, and I used this image just because Mitch had this really, really nicely outlined eye, and you can see the storm, the way it was spinning around there. All right, so here's our anatomy of the hurricane. You can see that they come in different sizes. So some are relatively compact, maybe 500 kilometers from side to side. Some might be much, much bigger than that. We have our low pressure center, that's the eye, and then surrounding it you have the eye wall. Your strongest winds will be in the eye wall, right? That's this area right surrounding the eye. That's where your strongest winds are going to be. And then these are called rain bands, the areas where as we get out from the eye. Now, some years ago, I think it was Hurricane Ike was 2008, I believe. This is our barometer at my house, and so a barometer measures atmospheric pressure. Normally, the needle's kind of somewhere around here. The eye did not go over my house, it went close by. This is right after the eye kind of passed over us, and you can see the pressure was much lower than what's typical around here. All right, so all of our natural disasters that we've learned about so far, people always want to measure them, right? We want to know how bad was it, how strong was it, right? And everything seems to have a scale used to measure that, whether it's the Mercalli intensity scale or the Richter magnitude or the volcanic explosivity index, whatever. All of these things have this scale. Well, for hurricanes, we use the Saffir-Simpson scale. And this measures the hurricane strength based on wind speed. And so what we have, we goes from category 1 to category 5. No, you're not going to get a category 6 or like Sci-Fi Channel, it was something like category 9, Day of Destruction. You're not going to have that because actually, eventually, when these storms strengthen so much, they will go through an eye wall replacement cycle. They actually kind of blow themselves a little bit apart and have to rebuild. And so we're not going to have a category 9 hurricane. We go from, of course, tropical storm and then category 1. You can see the winds will go up to 95 miles an hour in a category 1. There we have category 2, 3, all the way to 5. This gives you an idea also of the kind of storm surge these create. But we're going to talk a little bit more about storm surge in a few minutes. I do want to point out at this point in time that just because something is only a category 2 or only a tropical storm doesn't mean it can't cause significant damage. Hurricane Ike back in 2008 was a category 2 hurricane, caused significant damage in places. Tropical Storm Allison in 2001 was $1 billion weather disaster. It was a tropical storm, not even a hurricane. So don't start thinking that it's just a category 1, I don't have to worry. You know, you got to think, where do you live? Are you in a coastal area? Are you well inland? And think about what kinds of dangers you might be in for where you live and how strong the storm is. All right, just to give you an idea of what kind of damage you can expect with each of these categories, you can go to this website. This is through NOAA, National Oceanic and Atmospheric Administration, and they'll show you like what sorts of damage tropical storms, category 1, 2, and 3, and so on will cause. All right, where do our hurricanes come from? Well, they come from 2 typical places. They can develop at the Cape Verde Islands, and those are a group of islands off the west coast of Africa. And then a number of storms also develop in the Caribbean and Gulf of Mexico. We have a lot of warm surface water there and a lot of unstable, humid air in those places to develop into our hurricanes. Now, more tropical storms and hurricanes form when there is no El Nino. And that's because when there's no El Nino, West Africa is wetter. Remember I said these are islands just off West Africa? So what happens when there's no El Nino, you have a very wet West Africa, so you get a bunch of these thunderstorms developing, and those ultimately can create our tropical disturbances that will develop into a hurricane. When we have El Nino events, West Africa tends to be drier, so you just don't get a lot of those storms developing that can lead to our hurricanes ultimately. All right, I have a whole series of maps right here. Here's our Cape Verde Islands, right? Here's the Caribbean and Gulf of Mexico. And what we're looking at, these come from NOAA, and these are showing the typical places where hurricanes develop, or I should say tropical storms and hurricanes develop, and their typical pathways that they follow. And this is going month by month, so we're going to work through our entire hurricane season. So this happens to be June, and you can see in blue is the likely areas, green is the more likely areas, and orange, which is not on this map, are the most likely places that hurricanes will form. So there's June, there's July, there's August. We can see as the summer progresses and the water gets warmer, the air gets more humid, we tend to have a lot more places where these storms can develop. There's August, there's September, there is October, and there's November. So that took us through our hurricane season, showing you the different places where these typically form. Now, the pathway that hurricanes follow, it can be very difficult to forecast, but there are things that go into controlling and steering where our hurricanes go. So hurricane paths, a big influence on controlling where they're going to go is the Bermuda High. So the Bermuda High is this area of high pressure that sits out here, kind of sort of over Bermuda, but it does move around a little bit, and it kind of moves around in this area. So if the Bermuda High is sitting a little more to the east, the hurricanes come around, wrap around that high, right? Remember, hurricanes are low pressure, that's high pressure. They're going to curve around that high pressure, and they're going to stay in the Atlantic. But if this Bermuda High moves a little bit from the east, it moves to kind of more what we call a central location, that tends to make the storms come up and hit the east coast of the United States. But sometimes that Bermuda High moves a little more south. It comes from here and kind of moves into this area. Then it pushes the hurricanes into the Gulf of Mexico, and that's when here in East Texas we have to start getting worried. And so that's one of the big things that affects where hurricanes go, is exactly where is this high pressure system? Is it out here? Is it down here? Is it kind of in between? Where is that sitting? Now the other thing that affects hurricanes and their path are what we call temporal weather patterns. This means the day-to-day. Temporal means day-to-day weather patterns. So it's kind of like, where are the warm fronts? Where are the cold fronts? Where are the high and low pressure areas? And those will have an effect on pushing the storm one way or another, or pulling it and guiding where it goes. And those change every day. Hell, they change from morning to night. And so that's one of the things that makes exactly forecasting these very difficult to do.